in many internet service provider networks, so kind of the edge of the internet, where we have strong seasonal patterns in the traffic, they are low-hanging fruit. There are many of those small networks, so the benefits you can get there actually add up pretty quickly. And if they don't seem interesting, if you look at a single network, if you apply those principles everywhere, you can achieve very large effects. And that's something every network operator should have a look at, if only to reduce their energy bill.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello and welcome to Environment Variables, the podcast about green software. I'm Chris Adams, your host today, and filling in for Asim Hussain. And on this episode, I am joined by Yves Schouler of Intel. Hi, Yves.
Hi there.
And Romain Jacob of ETH Zurich in Switzerland.
Hello, everybody.
And today we're going to discuss the levers available to us for greener networking. Now, if we go by the figures from the International Energy Agency, data networks used around 250 terawatt-hours of electricity in 2019. And while we don't have the figures yet for 2022, this same agency is projecting an estimate of around 270 terawatts to be used by the end of this year, which, for context, is more than the entire electricity usage of Germany, the fourth largest economy in the world. This results in a significant environmental impact. And thankfully, we'll be talking with some people who've been spending a lot of time thinking about where the biggest levers are to do something about this in the context of the climate crisis. And they'll be sharing their research on how we can end up with greener, more sustainable networking. But before we dive into the specifics, let's do a quick round of intros. So maybe you can introduce yourself and your work at Intel.
Hi, thank you for inviting me. I am a principal engineer and I'm a director of emerging IoT networks at Intel. And my current work focuses on evolving the internet toward a sustainable edge-to-cloud infrastructure. My background and expertise is primarily in networking and distributed systems. And although I've spent much of my career in industrial research, I currently straddle a business unit at Intel called the Network and Edge Business Unit, and as well as the Corporate Strategy Office, where I'm responsible for sustainability, innovation, and standards. And I'd say that something that's really colored my experience is that I've spent much of my career heavily involved in internet standards and standards bodies such as NIST and the IETF, which is the Internet Engineering Task Force, where earlier in my career, I developed control protocols for internet telephony and multimedia teleconferencing. But at present, I'm heavily involved in and leading a working group focused on deterministic networks and their extension to operate in wireless networks. I'm also actively involved in the Open Group's Open Footprint Forum, and that aims to standardize the carbon footprint data model. So you can hear sort of my internet hat as well as the sort of sustainability hat, both coming to the fore.
Cool. Thank you, Yves. And thank you once again for getting up at the crack of dawn to join us from California today. Okay, Romain, I know it's somewhat more sociable time, so maybe I'll just give you a chance to introduce yourself and then we'll dive into some of this.
Yes, sure. So I'm Romain. I've been studying at ETH Zurich, Switzerland since 7 years for now. The first 5 I spent during my PhD on low-power wireless communications for embedded systems. So the question of how to save energy was kind of core to everything I was doing there. And after I graduated in 2019, I moved on to more internet research. And most recently, I've been interested into how can we reduce the energy consumed by networks in general with a focus on wired networks. And I'm trying to see to which extent the concept of low-power wireless networking could be translated into wired networks and how we could leverage that to make the internet more energy efficient.
Cool, thank you. And for context, I found out about Romain through the conference called Hot Carbon, which is a kind of energy and carbon nerd conference online where his paper how the internet of the future what was it? The internet of the future will grow old and sleep more. It was something like that that tickled me. I should introduce myself. My name is Chris Adams. I am the head of the policy group at the Green Software Foundation, and I'm also the executive director for the Green Web Foundation, an NGO based in the Netherlands campaigning for a fossil-free internet by 2030. And now you know all our names, maybe we should jump into the actual topic of greener networkings. So, Eve, I first came across your work with a recent paper called Towards Carbon Aware Networking. And in that paper, there was actually some useful information about setting the scene in terms of how much of the internet or how much of the tech industry, how much network makes up of this compared to, say, data centers and computing. I wondered if you might be able to just expand on some of that, because this is a useful piece of context. And previously, we've spoken primarily about data centers rather than the kind of aggregate impact.
Absolutely. I mean, in the press, we hear a lot about how data centers are consuming the world in terms of their energy usage. And it's interesting because there are studies that suggest that networking is as large or larger than the data center in terms of its consumption. And there are even, when you dig into the numbers a little further, networks have been estimated to consume as much as 1.5 times as much as data centers. And even within data centers, networks already account for between 10 and 20% of the energy there. So those numbers set the context, which is why it feels like networking deserves some further investigation and solutions.
So this is one thing that I might ask you, Romain, to come into on this, because previously, we've heard, while there are tools like, say, CO2JS or websites like Website Carbon, which will give you an idea of the environmental impact from, say, looking at a website, or you'll see stories about things like, say, the environmental impact of watching, say, Netflix, for example. But as far as I'm aware, the actual energy usage used by networks tends to be has historically been something which is relatively stable compared to the other usages from that. And I wondered if you might be able to expand a little bit on that part there. Like, is there scope for a change, or is it just a static figure that we have no matter how much we use the internet, really?
Yeah, so there is two points to this. One thing which is very true that relates to what you were saying is that the energy consumed by networks at any point in time, say in a time span of a year or a month, tend to be fairly constant. So there have been a number of studies that show this, that the energy consumed by the network is essentially independent of the load. So if you're using 10% of the capacity or 100%, essentially the same thing. The reason for this, so the stable number has increased over time as we've scaled up the networking infrastructure. But for a given infrastructure, the energy you consume, so the power you draw at any point in time, tends to be fairly constant. That's kind of worrying because we are typically operating very far from the 100% point. So we tend to over-provision our networks, meaning we want to make sure they are capable of much more than what we typically ask, which means that we essentially use a lot of energy all the time, whereas we're using the infrastructure fairly little.
So if I follow what you're saying, this is a little bit like maybe 10 or 20 years ago, before kind of pre-cloud, where you might have a big, fat, chunky server that you have and you plan for the maximum capacity. And as a result, it may be that if you look at, say, the usage you have there, because you can't really scale that server down, you've got that kind of relatively coarse-grained amount of energy usage. Is that the model that is actually helpful to think about when we're looking at the network usage here? Kind
of, yes. So when you talk about compute and you talk about what servers are doing, a lot of, depending on the workload you're actually working with, but you can scale up and down the power depending on how much compute you're producing. Whereas when you're looking at networking, it doesn't really work like this because you have very little compute that actually happens in the network. What the network consumes energy for is to powering the memory on which you read the routing information, for example, and the optics. So reading packets in and out. And all those things are essentially dominated by idle power, which is the power you draw just to turn things on.
I want to make a big distinction, which is that much of the core network has this property that whether or not you've got high usage, lots of packets flowing across it or not, it is going to have this constant amount of energy draw. But the wireless network inherently was taught from the beginnings of its design to be fairly adaptive. So I think that's the distinction. One of the distinctions being made here is that wireless and wired networks behave quite differently in the face of congestion or even just traffic on the network.
Yes, it's very true, very true.
Okay, so if I'm were to apply some kind of mental model for this, you might think about kind of like backbone networks as almost like kind of currents, deep ocean currents, which are constant the entire time. And then as the closer you get to the surface or to end users, you might have a bit more kind of spikiness going up and down. And that's like a way to think about where some of the levers for reducing impact might be. So if we're speaking about consumption, and that gives us some way to think about the energy used, there is another kind of source of leverage, which is the carbon intensity of the energy itself. And as I understand it, Eve, this was some of the work that was presented at Hot Carbon and some of the work that the paper that you've been contributing to towards carbon-aware networking. Maybe you might expand on some of that, because there are some really fascinating ideas I found in that.
Sure. I mean, as you alluded to earlier, there's been, at least in the data center community, an awareness of what is the quality, if you will, of the energy that is being drawn from the socket. And what I mean by that is, what is the carbon intensity? How low a carbon intensity can we get towards using clean energy or renewable energy? So the lower the number, the better. And data centers in recent years have begun to experiment with and now operationalize the idea of time and space shifting workloads to align with the availability of clean energy. That's interesting for a bunch of reasons, the most important of which is that, as Romain was saying earlier, the footprint for data centers and ICT, information communication technology continues to grow. And especially in the face of all the increased amount of data that we're sending across networks. And so pairing a data center with renewable energy enables us to reduce the carbon footprint of those data centers as they consume more energy. But similarly, in the electrical grid domain, we also have more and more integration of renewables. And in places like California, which is where I'm based, and in Germany and other parts of the world where that integration is happening quite rapidly, there are parts of the day where there's way more renewable energy than we can possibly consume. And so it just gets dropped on the floor, it gets wasted. And so there's been this lovely pairing of, we've got an entity that's consuming a lot of energy going to renewables, and the renewables creating excess and looking to somewhere to consume that. So you can think of compute as load balancing or as being virtual batteries for the data centers. And it begs the question that if networks are using 1.5 times as much electricity, why aren't we using those same techniques in networks? And so there is this growing awareness of where are the places where we can put renewables in order that networks are consuming cleaner energy, as well as and is it worthwhile to time and space shift the transmission of our network loads in order that they have a smaller carbon footprint?
Okay, so this is actually quite interesting to me for a number of reasons, because if I understand the most common tools we might use for sending packets of data around the world, we don't have that much control ourselves directly. So I might send something to the next hop, but there's something like the Border Gateway Protocol that decides where the next hop is, and so on and so on and so on. So I might have some indirect control there. And there are, say, clean slate attempts to redesign parts of the network or even introduce a notion of kind of path awareness from connecting, say, something you have now here to maybe a website, so you could take a kind of greener route like you have here. Would either of you have anything you could share there? Because as I'm aware, things like the Border Gateway Protocol, BGP, has maybe one main criteria that you have here. And it sounds like we might want to be able to use multiple criteria, like I care about latency, but I also want to balance that with carbon intensity, for example, or even cost. I'll open it up to see if anyone has anything they might want to share here that might help.
Yeah, so as you mentioned, BGP is kind of like the glue that connects the internet together. And it's been studied how to extend it, improve it, and change it over the past, 30 years or so. Various directions for various objectives. Usually security is the main concern that people have with BGP, but most recently there have been some different approach to go away from BGP. One example of that is the Cyan network or networking principle that is also coming from it, that is trying to let the end user pick which route the traffic should go through in the internet. So it's an idea that is generally known as source routing. So like the source of the traffic should say, I want my traffic to go through this network, then this network, until I reach my endpoint. And once you have this tool, so this is good for security purposes, but if you have this, you can also use it for carbon awareness. You could also say, I prefer to go through California because they have a lot more renewable energy rather than, some other state in the US that may not have as much.
Like Virginia.
For example.
West Virginia.
So it empowers you to do this if you want to do that. It is possible, yes.
Another way to have a mental model about this is network performance has often been categorized or has attributes like latency, like packet loss, like jitter, the variance in the latency, as metrics for the success of transmissions across the network. And so the idea is how to teach protocols, whether it's BGP or other parts of the network fabric, and even other parts of the network stack, about carbon intensity, so that carbon intensity is another metric that is a first-class metric in the selection of these routes, whether it's routes or whether it's software usage or whether it's scheduling. And so in some ways, we need to teach many of the protocols that we know and love in the internet about these additional options so that we can do joint optimizations or we can create source routes, as Romain was suggesting. But it is really very simpatico with this idea of deterministic networks in the small. Some of the work that is being done around time-sensitive networks, for example, is all around selecting paths or subnets that have the lowest latency and even creating multiple paths in order to ensure that packets get delivered in time. But what if the constraint that we really wanted to optimize for in certain circumstances was the carbon intensity? And it really also leads us to ask, how do we educate all of this software that's out there to not only carbon intensity information about the location, carbon intensity is very location, time and space specific, but how do we also enable our applications to say how time elastic they are in order to be shifted around or delayed? So they're both issues to solve.
All right. So what this seems to be speaking to is this idea of moving from maybe just one set of criteria to wider set. So, for example, if I cared about latency more than cost, I might care about things like, say, if I'm doing a video call in Australia, I might be prepared to care more about latency than the cost of, say, for carbon. And if I cared about, say, doing a download of Netflix for a video, I might, if I'm not going to watch it right now, I might say, well, I care more about the cost and the throughput, not latency, and making it go through a kind of green route. So I would rather have some kind of low carbon internet trick shot bouncing through the greenest possible places to end up on my computer for when I come home tonight, for example, or something like that. That seems to be some of the directions this might be heading towards. Okay, wow, that's quite exciting, actually. So this also speaks to these ideas of maybe changing how we might design software in the first place and having different tolerances. Maybe, Eve, you might be able to speak to this a bit, because you mentioned this phrase I haven't come across before, time-sensitive networks. So maybe you could expand on some of that and some of the delay on the flip side of that, which presumably will be delay-tolerant networks for this.
Yes. Time-sensitive networking community is, for example, some of the work that I've been involved in recent years comes out of the Internet of Things group at Intel, and in particular, the industrial Internet of Things contexts where you've got control systems that have very, very low latencies, less than a millisecond, for example. And so you're talking about subnets, very small networks. But some of the work in the IETF is about, well, how do you, across factory floors, how do you enable them to be time sensitive across subnets, which may have different underlying technologies? And so all of them need to be taught sort of how to do this. Now, in the time-sensitive networking world, often one of the strategies, in addition to, as I mentioned earlier, multipath, having multiple paths by which packets can go between sources and destinations. So there's redundancy for reliability, but there's also the reservation of resources along the path. And for that, it starts to look a little bit like what we were talking about when Romain was referencing the Scion work. What if you knew how much time it took you along each hop and you had a certain budget? Well, you could send out a query message between a source and a destination to understand along the way, cumulatively, how much latency am I going to encounter, reserve enough buffers in those queues, and eliminate congestion along that path. And that's sort of what time-sensitive networking in the small has been doing. Now, the kinship that it has with delay-tolerant networks is that we want to expand these time-sensitive networks. We want to teach them about energy usage and energy awareness, carbon awareness. But these delay-tolerant networks, back to the data center analogy, data centers are shifting their workloads to align with when the sun's shining or the wind is blowing. And so they're holding on to their workloads. There's been a long-standing project in the networking community around delay-tolerant networks that have been designed primarily for deep space. And because routers come and go because planets align in certain ways or satellites align in certain ways and they're not always there. And so that's why they have to be delay tolerant. There's this dynamic of the availability of the resources. And so the question is, could we be using delay tolerant networking in context for more than just satellites? In this context where we want to align with the availability of clean energy.
Yeah, no, I think I totally agree with what Eve was saying. And this idea of delay tolerance or more delay tolerance, or more tolerance in general in networking is necessary to progress towards more energy efficiency or carbon efficiency. This is essentially what wireless networks, as Eve was saying, have been doing forever. Right? In wireless, how do you save energy? Well, you keep things off for as long as possible. Right? You try to make sure that when you turn on your radio is to achieve something useful, and then packets will go through and as efficiently as possible. And if you think of it, it's extremely easy to push the energy efficiency, right? What do? Well, you turn off for 90% of the time, and then you schedule very tightly the time where you stay on. The problem is that induces delay, right? And your application is to be able to tolerate that delay. And embedded systems, IoT, all this work, this field has been working in the different trade-offs to play with this, so that the application performance does not degrade too much due to the delay induced by the networking part. And that's like the story of what I've been doing during my PhD. The problem is that the internet networks, the wired networks, they've been built in a different paradigm. Okay? It was all about reliability. It's been designed to be as reliable as possible. Like, if we have a nuclear war, the internet should still work. Like, that was the initial idea, right? So we need to make sure to provide all level of reliability possible to sustain anything. But we need to get away from this now, because the cost of this is that we over-provision everything, we have a lot of redundancy, and we use very little of that. So some of the things that I'm thinking about together with several colleagues now is that, okay, what if we were to redesign indeed those wired networks so that reliability is not something we get rid of, but we modulate the requirements we set there and say reliability is just one objective. How much performance degradation are we willing to tolerate in order to save on energy? To give a very concrete and simple example, most traffic on the internet is driven by human activity, right? And human activity has a very clear seasonal pattern. We use the networks more at certain times of the days and not at others. It's very easy to think that we could turn off part of these networks for a certain part of the day because we don't need that much bandwidth. And if we do, we might be able to tolerate a bit more delay than at peak hours. It's very similar to turning off the public lights on the street, at night when nobody's driving, right? It's the same principle.
Or even in your home, right? The analogy of one's parents growing up, don't forget to turn off the lights. It's exactly the same analogy.
Yeah, it's the same idea, right? And there is no reason this cannot be done. We know we can do it. The question is, how far can we push it? And one limitation factor, one blocking factor at the moment is how quickly we can turn things on and off. Because switching on a router or a switch takes, as of today, in the orders of several minutes. Right, so it's not something that you can just do multiple times per hours or so, because essentially your network will be completely inoperable. It can be changed. If we were to change the hardware, if we were to change the operating system we run on those machines, we could improve on that. How far can we go? This is kind of an open research question at the moment.
That's really helpful, and thank you for explaining it in that way. I presume this is the internet must sleep more part of your paper, where the internet must sleep more and grow old, right? What you're talking about here is actually the idea of things not necessarily being away, are there all the time, or the idea of liability moving to different parts of the system is actually quite an interesting one, and one we've seen with the cloud, yeah.
And actually, there are a couple of seminal pieces of work that I think we can look back on as really setting us down this path. So, for example, Maruti Gupta's work in 2009 from SIGCOM was all about, energy efficiency and beginning to examine how much could we save if we began to turn things off. Another interesting paper that's been influential is Dina Papagiannaki's work, Access Points, and whether parts of the wireless edge network could be, internal to buildings, be turned on demand. So it's sort of the opposite idea of like turning things off, but it's like you turn things on demand. And as Romain suggested, we understand the patterns of usability of those things. We know when people come into buildings, whether they're in their homes or whether they're in their offices. And so an on-demand infrastructure at the very edges of the network makes a lot of sense. So those are two pieces of work that certainly have influenced my views on teaching devices how to sleep.
Okay, cool. And this idea of matching demand to supply, Eve, you mentioned about kind of speaking in California. I mean, just this week, we saw a really good example of demand response where you saw like a CAISO, the grid operators, basically say, hey, folks, we're about to kind of hit a blackout. Can everyone please just turn things down a little bit? And if I understand it correctly, we were able to see basically one of the largest grids not fall over. And this is like an example, you don't only just have to think about supply by the sounds of things.
And it raises an interesting question, because how much of the network involves the user? How actively attentive are users when they route across the network? Right now, there's very little engagement. So one of the issues that we probably need to solve is creating, as you were referring to them, levers at different points in the architectural software stack and even in the hardware design that allows different levels of involvement for users that have different capabilities or interests in enacting those levers. All week, we have been receiving warnings about the coming temperature. It was 109. Unheard of here. It broke all records the other day. But that was through constant messaging that we were asked to please be considerate during the hours, in particular between 4 and 9 p.m. I guess that's when people begin to come home and turn on their air conditioners. The network doesn't do that. It doesn't ask you to be thoughtful, but maybe our software and our software development practices need to incorporate this.
Thank you for that. So for other listeners, we did cover some of this in episode 9, where we speak about carbon-aware computing and the idea of annotating, say, jobs for Kubernetes or other schedulers to basically say, yeah, I can wait a little while. I'm important, but not urgent. But it sounds like this reminds me of a blog post by a guy called Ismael Velasco. He's in the climateaction.tech Slack, and he's been speaking about the idea of, is there a chance to extend some existing protocols, like, say, we have Open API for describing how APIs work on the web, and there is an async API, which is another way to say which is, as far as I'm aware, is used for lots of kind of programming tools these days as a way of saying to do the same thing but asynchronously. And there's some work there to basically extend this with this notion of delay tolerance or location tolerance, so that you can basically say this thing is important, but it's not so urgent. In the same way that with an operating system, with Apple's, for example, you can annotate particular tasks to either be returned very, very quickly for high latency when there's users, or something which might be better suited to a low power core in a computer. So maybe this is actually the thing I want to ask. is right now we spoke about some kind of cool future things. If I could bring this to some of the stuff that's happening right now these days, if people are listening to this and they want to do something or start playing around with some of these ideas, where should people be looking? What kind of software is out there? What kind of tools exist for people to kind of experiment with some of these ideas to play it with their own time, or even possibly build some cool new services on top of, for example?
A couple of thoughts, at least. One is that at Intel, there is a dynamic power management solution that exists called Speed Select technology. And it does allow you to dynamically adjust the frequency of cores. And there's some interesting description of that technology at the most recent ICIN conference in 2022 in a joint paper with British Telecom. There was a paper on NFV and energy efficiency describing that service. But for developers, I would say some of the most interesting APIs I've come across are from, there are quite a few offerings to get carbon intensity information from the electrical grid, but use it in computing systems. And some of the interesting APIs are from Watt Time and Electricity Map. And so I would say you could play with those to see, whether you want to incorporate both carbon intensity and understand what the patterns are of the carbon intensity where you reside or where you want your workloads to reside. I also wanted to put in a plug for a workshop that's coming up that's being hosted by the Internet Engineering Task Force on environmental impact of Internet applications and systems. And the deadline for putting in publications, Romain,
I'm aware,
is the end of October. And with the workshop happening in December. And then finally, one of the things that's been, I wouldn't say bothering me so much as frustrating me, is the long lag time between our assessment of the overall internet footprint and the time that goes to publication. There's a small group of people who diligently publish these assessments, but it's really backbreaking work to understand where are the pain points in the infrastructure and topology. So I would provide a call to action, if you will, for networking researchers involved in the internet to help speed the accurate and timely assessment of the networking and overall ICT energy usage by participating in and contributing to these ITU documents. It's called L.1470, but its name, human readable name, is the GHG for greenhouse gas trajectories for the ICT sector. So if you have some insights into the pain points of the internet's energy usage, where we could be more efficient, turn things off, age things longer, be aware of carbon intensity, we'd like to hear from you.
When you spoke about that does remind me that, so this is the Green Software Foundation podcast, and I would be remiss to not mention that there is a Green Software Carbon Aware SDK specifically that wraps some of these APIs that you're able to use. I think it's primarily written in .NET, but I believe there might be a Go build of some of this as well. Independently of this, the organization I work for, the Green Web Foundation, we've built a CO2.js, which basically has a lot of the kind of carbon intensity figures inside it now, and also Grid Intensity Go, which is a Golang library specifically designed to allow you to essentially, again, wrap these APIs and use them in scheduling tools. The other work that might be worth being aware of is that there's some work with RIPE, which is the people who issue IP addresses in Europe. They've been funding us our NGO, to basically annotate every single public IP address on Earth with carbon intensity information. So if there's a chance to build some of the green routing stuff, we have an API, which is API to carbon intensity from our organization that will give you some figures for free, but these are annual. These are not going to be fluctuating or updating the way that WattTime and some of the other providers do. There's also some work from Singularity, who've recently started sharing some information and hourly resolution all across America for people to be looking at this.
One point I wanted to make is that I do agree that this question of carbon intensity and carbon awareness is important for sure. We need to be able to improve on that metric. But we should not forget that at the end of the day, the best energy is the one we do not consume. And so we should also keep investing efforts into being more energy efficient, while keeping in mind that consuming less energy, if its energy has to be more carbon heavy, is not necessarily the best trade-off. Still, we should look at the low-hanging fruits in reducing the energy we consume for the current service the networks are providing. And I mentioned earlier already today this study of seasonality, analyzing the level of redundancy that are existing in networks. I think in many internet service provider networks, so kind of the edge of the internet, where we have strong seasonal patterns in the traffic, they are low-hanging fruits. And as F's paper of Hot Carbon was mentioning, there are many of those small networks. So the benefit you can get there actually add up pretty quickly. And if they don't seem interesting, if you look at a single network, if you apply those principles everywhere, you can achieve very large effect. And that's something every network operator should have a look at, if only to reduce their energy bill.
I think you're absolutely right, Romain. I think there are three things to consider, actually, when we think about green networks. One is, first and foremost, this energy efficiency. Use less. If you're going to use energy, ensure that it's decarbonized. But then there's this third facet, which we haven't even touched on, which is the other environmental impacts, whether that's water or toxicity or air pollution, whatever it is, that also need to be somehow captured in metrics as well and ultimately comprehended.
We're running short on time, so I'm going to ask one question just because it's very rare to have people who understand the network to help answer this question. So for people who might know people who feel bad about, say, watching Netflix or feeling guilty about being on video calls, would either of you have something to say to people who might be struggling with this to maybe put their mind at ease or help kind of come up with a mental model? Like, should they be feeling bad about the environmental impact of the video calls they make or the videos they're watching after work?
I don't think trying to feel people guilty will change anything, because people don't have the levers to change anything. Like most individuals, like you and me, I mean, you open your laptop, you have a service provider, and you don't have any control. I mean, you can choose provider A or provider B, and they may sell you some broad characteristic of the internet connection they provide you with. But I mean, you can monitor this if you're an internet geek and you care about these sorts of things, but you cannot really influence where it goes. It's not exactly true, but in practice, the individual has very limited control. The network providers do. That at this level, then that things need to be changed. Now, that being said, you can still do something, right? You can, for example, just be considerate before consistently streaming and uploading to clouds gigabytes and terabytes of pictures in multiple providers, because you care that if Google goes down, then Facebook is not, and you can still access your things, Yes, but how many people are actually doing this? I don't think so. I don't think so many.
Okay, so there we have from someone who's on the final stages of their PhD. And Eve, is there anything you might add for people who are wrestling with this particular issue themselves when they open up Zoom to speak to a loved one or anything like that themselves?
I think it's like anything else in our lives. We need to be acculturated to thinking about this as an issue. I don't think we should have that much guilt about it, but we should be thoughtful. And so if it doesn't make a difference in the communication to have the video when you're just a participant versus a speaker, or if you can do low def versus high def, those are really easy decisions. And I think there will come a time when people will be asked to fit within budgets of carbon footprints and companies and so forth. And so we'll have to do our part. So we should be getting in the habit of at least thinking about these things. But as others have said, we don't have that many choices except on or off. It's sort of a Boolean choice, maybe, one resolution or not. And something about teleconferences is we save a tremendous amount using teleconferencing technology over air travel and other forms of travel. So it's incrementally we're getting more and more efficient. As to all those Netflix that we're watching, that's another concern. Again, maybe we'll be given a budget in time.
All right. Okay. Thank you for that. So from what I'm hearing, it might not be the case that streaming is indeed the new flying. So that's one thing that we could take into account. All right. We're just going to wrap up now. For people who have enjoyed this and want to learn more, where can people find you online, or where should they be going to learn more about the work that we've discussed here?
Yeah, so you can find me on my website, romainjacob.net. This is where you will find most work-related updates. Otherwise, with my name, it will be easy to find on Twitter. I will not read my handle because it's unreadable. But my name works fine. I tried before.
Okay, excellent. All right, we'll be adding the links in there. And Eve, if people have been interested in some of the stuff you've been talking about, where should they be looking?
Similarly, you can find me at eveschuler.com and LinkedIn as well.
Okay, I'm really glad. Folks, I really enjoyed this session, and I think that we've covered a lot of really quite helpful ground for other people who are wrestling with this and are just curious about this. For the listeners, thank you very much for listening to Environment Variables. All the resources for the podcast will be available at podcast.greensoftware.foundation, along with copious show notes with all our links for this. If you did enjoy this, please do write a review on wherever you're hearing your podcast. It really does help us find new audiences. And yeah, that's us. Cheers, folks.
Bye-bye.
Bye.
Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.